Okay, hello everyone in a new video. So we have reached part 3 of chapter 4, which is the chapter of resistors and the second unit of electricity. In this one we are going to solve some exercises. Then let's start by extra exercise number 2. They are telling me document 1, they mentioned document 1, then now we can use it. Represents the characteristic current voltage curve of a given electric component. Number 1. They are telling me this electric component can be considered as an ohmic conductor, justify, and by an ohmic conductor it means a resistor. So in order to justify that this electric component is a resistor, we need to refer to the shape of the curve. So notice that this curve represented in UI system is a straight line passing through the origin. So let's say since the shape of the characteristic current voltage curve is a straight line passing through the origin, then whenever the shape of the curve of the characteristic current voltage curve is a straight line passing through the origin, then the electric component is a resistor, or in other words, ohmic conductor. Now in number 2 they are telling me determine its resistance R, and we know that the value of R can be determined using the slope method. So step number 1 is to write the definition of the slope, which is given by the resistance of the resistor. Is equal to the slope of the characteristic current voltage curve So this is step number 1. Step number 2 is to choose any 2 points belonging to the curve. Then let's choose the point A and another point, which is the point B. So we can choose any 2 points belonging to this curve. The coordinates of the point A are given by, so we always start by the current then the voltage. So it's given by 1 ampere and 55 volts. And whereas for the point B, it's given by 3 amperes and 165 volts. So this is it for step number 2. Now in step number 3, we need to make sure that these quantities are in the SI. So already these quantities are expressed in the SI. Then now we are ready to calculate the slope, which is the resistance, which is given by R is equal to UA minus UB divided by IA minus IB. Now the value of UA corresponding to the voltage of the point A, which is given by 55 volts, because the voltage has the unit of volts, so 55 minus the voltage of the point B, which is given by 165, and the current of the point A, which is given by 1, and the current of the point B, which is given by 3. Now plugging this fraction on the calculator, then the value of R is given by 55. Since all of these quantities are expressed in the SI, so the value of R will be in the SI, which is ohms. Then R, which represents the resistance of the resistor, is given by 55 ohms. So this is it for extra exercise number 2. Now as for extra exercise number 3, they are telling me document 2. So they mentioned the document, now we can use it, represents the characteristic current voltage curve of a given electric component. Now in number 1, they are telling me this electric component can be considered as an ohmic conductor, justify. So by ohmic conductor it means a resistor. And the nature of the electric component can be determined by referring to the shape of the curve plotted in the current voltage system. Notice that it's a straight line passing through the origin. Then the nature of the electric component is a resistor. So this is the justification. So let's say since the shape of the characteristic current voltage curve is a straight line passing through the origin, then the electric component can be considered so let me say is a resistor. And between the brackets, this is an ohmic conductor. Now in number 2, they are telling me determine its resistance R, and because we have a graph, R can be determined using the slope method. The slope method consists of 4 consecutive steps. Let's start by step number 1, which is writing the definition. The resistance of the resistor is equal to the slope of the characteristic current voltage curve Then the next step is to choose any 2 points belonging to this curve. For example, let's choose this is the point A and this is the point B. Now let's locate the coordinates of the points A and B. The point A has a value of electric current given by 4 amperes and of voltage 176. As for the point B, it has an electric current given by 5 amperes and electric voltage given by 220 volts. Now step number 3, or the third step, is to make sure that these quantities are given by in the SI, so they are already given in the SI. Now let's move to step number 4, which is the final step, and calculating the resistance R, which is given by UA minus UB divided by IA minus IB. So independent by which point we start, but the important thing is if in the numerator we started with A, then in the denominator we start with A, and if in the numerator we have ended with B, then in the denominator we will end also with B. Now UA represents the voltage of the point A, which is given by 176, minus the voltage of the point B, which is given by 220 volts, divided by the electric current at the point A, which is given by 4, minus the electric current at the point B, which is given by 5. Plugging this fraction on the calculator, then it's given by 44. Since all of these quantities are expressed in the SI, so the value of R will be expressed in the SI, which is ohms. So R in this case is equal to 44 ohms. So in extra exercise numbers 2 and 3 we have determined R by referring to the graph. Now let's move to extra exercise number 4. In number 1 they are telling me document 1 shows the 3 resistors given by R1, R2 and R3. Determine R equivalent, the value of the resistance equivalent to R1, R2 and R3, knowing that R1 is equal to 20 ohms, R2 is equal to 15 ohms and R3 is equal to 30 ohms. Then we are interested in determining R equivalent. So let me write number 1. In order to determine the equivalent resistor, first we need to identify whether these components are in parallel or in series. So they are in series. Then as a title, let's say R1, R2 and R3 are in series. So usually this statement, they give it half a mark. So in this case, R equivalent is simply given by the sum, which is given by R1 plus R2 plus R3. So the value of R1 is given by 20. The value of R2 is given by 15. And the value of R3 is given by 30. So R equivalent is given by 65. Since all of these are expressed in the SI, which is ohms, then the value of R equivalent will be expressed in the SI, which is ohms. So R equivalent is given by 65 ohms. And whenever we calculate an equivalent resistor, we represent this equivalent resistor replacing the resistors. In this case, they are given by R1, R2 and R3. So the points B and C will disappear and R equivalent will be across the terminals A and D. This is the point A, this is the point D, this is R equivalent of value R equivalent is equal to 65 ohms. Now as for number 2, let me make some space here. They are telling me document 2 shows the 3 resistors given by R1, R2 and R3, knowing that R1 is equal to 50 ohms, R2 is equal to 20 ohms, and R3 is equal to 30 ohms. So in 2.1, we are interested to determine R prime, the value of the resistance equivalent to R2 and R3. Okay, so whenever we need to determine an equivalent resistor, we need to specify whether the resistors initially are the type of the grouping. So notice now that R2 and R3 are in parallel. So here, this grouping consists of 3 resistors, R1, R2 and R3. We are interested in determining R equivalent just for this grouping, okay, and not for the whole grouping. So R2 and R3 are in parallel. Why they are in parallel? Because they have 2 terminals in common that are given by B and C. And we know that the formula of R equivalent is given by 1 over R2 plus 1 over R3. Notice that in this case the equivalent resistance is denoted by R prime, so we use the same notation. Then 1 over R prime is equal to 1 over R1 plus 1 over R2, R2 plus R3. So notice that this statement, they usually give it half a mark, and for this formula, they give it 1 over 4, okay? Now, the value of R2 is given by 20, so 1 over 20, plus the value of R3 is given by 30. Now here we need to be very careful because we are adding 2 fractions, so we need to consider the common denominator, then the simplest form. Or in this case, we can simply plug these fractions on the calculator. So then their sum is given by 1 over 12. And in this case, 1 over 12, what does it represent? It represents 1 over R prime, knowing that we are interested in determining R prime. So 1 over R prime is equal to 1 over 12. So now if we cross multiply, then the value of R prime is equal to 12 ohms. And as we have said previously, whenever we determine an equivalent resistance, we need to represent this resistor in the given electric circuit. So in this case, R prime is the equivalent resistance of resistors of R2 and R3 across the terminals B and C. So here we have the resistor R1 across the terminals A and B, and we have another resistor given by R prime across the terminals B and C. So now, okay, as we proceed, we need to consider two electric circuits that are given by this and by this, and we will use the easier in our calculations, okay? Now in 2.2 they are telling me deduce R equivalent, and by deduce it means that we need to use the previous part, which is R prime. So this is a side remark. R equivalent, the value of the resistance equivalent to R1, R2 and R3. So we need to determine the equivalent resistor that replaces R1, R2 and R3. Already we have determined the equivalent resistor corresponding to R2 and R3, which is denoted by R prime. Now it's left to determine R equivalent. So in this case, let's consider this circuit in order to determine the R equivalent. Instead of determining R equivalent between R1, R2 and R3, we will determine R equivalent for R1 and R prime, because we have already determined for R2 and R3, and this justifies why part 2.2 starts with deduce. So in this case, let me say that R1 and R prime are in series. So they are in series because they have one terminal common, which is the point B. Then its equivalent resistance, which is denoted by R equivalent, is equal to R1 plus R prime. The value of R1 is given by 50, and the value of R prime is given by 12. So this is equal to 62. Since both R1 and R prime are expressed in the SI, which is ohms, then the value of R equivalent will be expressed in ohms. So R equivalent is equal to 62 ohms. And whenever we calculate an equivalent resistor, it's convenient to represent this equivalent resistor in the given electric circuit. It replaces the terminals A and C, then it's given by this. Of value 62 ohms. Now as for extra exercise number 5, they are telling me document 3 shows 4 resistors given by R1, R2 and R3 and R4, knowing that R1 is equal to 5 ohms, R2 is equal to 8, R3 is equal to 8, and R4 is equal to 45 ohms. And number 1, they are telling me to determine R prime, the value of the resistance equivalent to R2 and R3. Notice that R2 and R3 are in parallel. So usually this statement, they give it half a mark. So notice that here we are determining equivalent resistance just across the points B and C, and not of the whole grouping. This equivalent resistance is denoted by R prime. We use the same notation, which is equal to R2 plus R3. Sorry, they are in parallel. So R prime is related to R2 and R3 via the following formula, that 1 over R prime is equal to 1 over R2 plus 1 over R3. Because they are in parallel, we use this formula. Now the value of R2 is given by 8, so 1 over 8 plus 1 over 8. Now we are adding two fractions. So whenever we are adding two fractions, we need to consider the common denominator, then the simplest form, or we can simply plug this on the calculator. It's given by 1 over 4. So in this case, we have determined 1 over R prime and not R prime. So 1 over R prime is equal to 1 over 4. And in this case, R prime is equal to 4 ohms. And whenever we calculate an equivalent resistor, we need to consider this equivalent resistance again in the given grouping and represented. So it replaces the points B and C. So we still have the points A and B, across which we have the resistor R1. R2 and R3 are replaced by R prime. And here we have the point D, so this is R4. Now in part 2, they are telling me deduce R equivalent, and by deduce it means that we need to see the previous part. The value of the resistance equivalent to R1, R2, R3 and R4. So here we have two groupings. Whenever we are being asked, we could refer to each of them. So by deduce it means that we need to use the previous part, which means we need to use this grouping. So the equivalent resistance between R1, R prime, R4 is exactly the same of R1, R2, R3 and 4, because R prime simply replaces R2 and R3. So in this case, let's say that R1, R prime and R4 are in series. As a title, so usually this they give it half a mark. In this case, R equivalent, which is denoted by R equivalent, is equal to R1 plus R prime plus R4. The value of R1 is given by 5. The value of R prime is given by 4. And the value of R4 is given by 45. Now plugging this on the calculator, then it's given by 54. Now since all of these are expressed in the SI, which is ohms, then the value of R equivalent will be expressed in ohms. So R equivalent is equal to 54 ohms. So this is it for this exercise. Now for extra exercise number 6 in part 1, they are telling me document 4 shows the 3 resistors given by R1, R2 and R3. Knowing that R1 is equal to 5 ohms, R2 is equal to 14 ohms, and R3 is equal to 16 ohms. So now 1.1, they are telling me determine R prime, the value of the resistance equivalent to R2 and R3. So here the whole grouping consists of 4 resistors, R2, R3 and R1. We are interested just only in the equivalent resistance that replaces R2 and R3. So let's say that R2 and R3 are in series. So usually this statement they give it half a mark. Now this equivalent resistance is denoted by R prime. So in this case R prime is equal to, so R2 and R3 are in series because they have one term in common, which is the point B. Now R prime is equal to R2 plus R3. The value of R2 is given by 14. The value of R3 is given by 6. So this is equal to 20. Since both of these are expressed in SI, which is ohms, then the value of R prime will be expressed in SI, which is ohms. So R prime is equal to 20 ohms. And whenever we calculate an equivalent resistance, we need to represent this resistor in the given electric circuit. So notice that R prime is equivalent to R2 and R3, so it replaces R2 and R3. Then the point B will disappear. We still have the point A. This is R prime. And this is R1. Okay, this is the point C. Now in 1.2 they are telling me deduce R equivalent, the value of the resistance equivalent to R1, R2 and R3. So and by deduce it means that we need to use the previous part. In the previous part we have determined R prime, the equivalent resistance between R2 and R3. Now we are interested in determining the equivalent resistance, the resistance equivalent to R1 and R2 and R3, replacing the points A and C. So it's more convenient to use this electric circuit because now A and R prime and R1 are in parallel. So this statement they usually give it half a mark. So in this case 1 over R equivalent is equal to 1 over R1 plus 1 over R prime. So this is the formula relating equivalent resistance. The value of R1 is given by 5 and the value of R prime is given by 20. Now notice that here we are adding two fractions, so we need to consider the common denominator. We need to consider the common denominator, then we need to simplify it. But we can use directly the calculator, then it's given by 1 over 4. So 1 over 4 represents 1 over R equivalent, so 1 over R equivalent is equal to 1 over 4. So in this case, the value of R equivalent, if you cross multiply, is given by 4 ohms. And whenever we calculate an equivalent resistor, it's convenient to represent it in the given grouping. So this is the point A, this is R equivalent, and this is the point C. Okay. Now extra exercise number 7, they are telling me document 1, they mentioned the document, now we can use it. Shows an electric circuit consisting of a DC voltage source such that UPN is equal to 24 volts. So the trick in solving such type of exercises is to write the applied voltage on the electric circuit itself, the applied voltage and the traverse current. So the value of the battery is given by 24 volts. An ammeter A of negligible resistance, a voltmeter V, a lamp L carrying the following indications 6 volt and 0.5 ampere. Notice that these indications are corresponding for the lamp L. Notice that I didn't label these indications here because yet we don't know if the lamp L is functioning normally. A resistor R of resistance R and a switch K. The aim of this exercise is to determine the value of R that allows the normal functioning of L. Then this is important, okay? Now number 1, they are telling me initially the switch K is opened. In 1.1, so is there any electric current traversing the circuit? Justify. So notice that an open switch doesn't allow electric current to pass through because this is a disconnected terminal, okay? So let's say an open switch doesn't allow electric current to pass through. In this case, the value of the electric current I is equal to 0. Now in 1.2, they are telling me what is the value of UAB across the open switch. Justify. We know that the switch operates in two modes, open or closed, and an open switch always have in series with the battery has the same voltage of the battery. Then the justification is given by an open switch in series with the battery has the same voltage of the battery. So in this case, the value of UAB is equal to 24 volts. Now in 2.1, so 2, now the switch K is closed, so let's close the switch. An electric current I is traversing the circuit, so we have an electric current I. So notice that here the electric current doesn't traverse the voltmeter, okay? And always the direction of the electric current is from the positive pole to the negative pole. Hence the lamp L is functioning normally. Since now the lamp L is functioning normally, so it has the same values of the indications. Notice that it carries two indications that are given by 6 volt and 0.5 amperes. So the voltage UCD across the lamp is given by 6 volts and its current is given by 0.5 amperes. So now actually we have determined the main current traversing the circuit because the lamp is in series with the resistor and the battery. So let's see. In 2.1 they are telling me what does each of the indications carried by L represent. Let's say 6 volts, so volts is the unit of voltage, so it's the rated voltage, of which electric component we have 3. The lamp, the resistor and the battery, so it's corresponding for the lamp, so rated voltage of the lamp L, under which it functions normally. Now as for 0.5 amperes, it's the rated current of the lamp L, under which it functions normally. Now in 2.1 they are telling me what's the value of UCD across the lamp, justify. So they are asking me about the voltage UCD across the lamp, and it's already given by 6 volt, and the justification is given by it's functioning normally. So let's say since the lamp L is functioning normally, then in this case, then the applied voltage is equal to the rated voltage so the voltage of the lamp, which is given by UCD, is equal to 6 volts. And here notice the following: since they are asking me about voltage across a branch, so we expect that they will ask us about the law of addition of voltages. So indeed in 2.3 they are telling me determine the voltage UBC across the resistor. We know the voltage of the battery, which is given by 24, and we have the voltage of the lamp. We can determine the voltage of the resistor because across P and A we have a connecting wire, its voltage is 0. Across A and B its voltage is 0 because it's closed switch. Across D and N we have an ammeter and its voltage is 0, and the reason is given by negligible resistance. So as a title, let's say apply. So here we are in part 2.3, apply law of addition of voltages So always on the left we write the voltage of the battery, which is given by UPN, and on the right hand side of this equation we'll go from P to N across different electric components starting from P and ending with N. So from P to A, keeping in mind that UBC must appear in the equation. So UPA plus UAB plus UBC plus UCD and D back to N. So notice that we have started with P, ended with N, and each letter we have inserted twice. Okay, knowing that we are interested in determining UBC. Now UPN is equal to 24. UPA across P and A we have a wire, so UPA is 0, and we didn't justify this previously, so let me write here between brackets UPA is equal to 0. The reason is given by connecting wire. Now across A and B we have a closed switch, so it's 0. We didn't justify this previously, so let me say that UAB is equal to 0, and the reason is given by closed switch. Now UBC is kept as a variable because we are interested in determining UBC. As for UCD, UCD is given by 6 plus UDN. Across D and N we have an ammeter, so it's 0, and the reason is given by negligible resistance. So this is given by 24 is equal to UBC plus 6. So What's the type of this equation? This is a linear equation and one unknown. The unknown is UBC. How do you solve this equation? We put UBC on one side and all the others on the other side. Then UBC is equal to 24 minus 6. This is equal to 18. Since both 24 and 6 are expressed in volts, so the value of UBC will be expressed in volts, which is 18 volts. Then UBC is equal to 18 volts. And I repeat, whenever we calculate an applied or traversed voltage or current respectively, we need to label these quantities on the electric circuit itself. So this is 18 volts. Now they are telling me in 2.4 what's the value of the current I traversing the circuit justify. So because the lamp L is functioning normally, the value of I is equal to 0.5 amperes. So no need to do any calculation because or to perform any calculations because L is already functioning normally. So let's say since the lamp L is functioning normally, then the value of the traverse current is equal to the rated current. So in this case, the value of I is given by 0.5 amperes. Now in 2.5, they are telling me deduce the value of R, and by deduce it means that we need the previous part. In the previous part, we have justified that the value of I is given by 0.5 amperes. We are interested in determining the value of R, knowing that also the applied voltage is given by 18. So knowing the voltage, knowing the current, the value of R can be determined by Ohm's law. So apply Ohm's law. And here Ohm's law can be applied to different electric components. Notice that we are applying it to R. And this statement is very important. They usually give it half a mark. Always in physics we need to mention the law that we are using. Then Ohm's law is given by U is equal to Ri. So whenever we apply Ohm's law, we always write these two. Now we are interested in determining the value of R. So constructing the triangle of this formula, here because we have multiplied, then U will be at the top, R and I at the bottom. Putting our hand over R, then the value of R is given by U divided by I. U is denoted by UBC, and its value is given by 18. The value of I is given by 0.5. Now plugging this fraction on the calculator, then the value of R is given by 36. Since U and I are expressed in the SI, so the value of R will be expressed in the SI, which is ohms. So R is equal to 36 ohms. And here let me say the following. Now the lamp L has a rated voltage which is given by 6 volt. If we want to connect the lamp L directly to the battery, the lamp will burn out because it has a rated voltage. So because we are applying a voltage which is greater than the rated voltage. In order to protect this lamp and make it function normally, we must connect a resistor R. The problem is that what's the value of this resistance is given by 36 ohms. Okay. Now in 2.6, they are telling me give with the justification the reading of the voltmeter. So the voltmeter is connected in parallel across R, so it's measuring 18 voltage, but depending on the COM terminal, it will either measure plus 18 volts or minus 18 volts in order to determine whether it measures a positive or negative reading. So if this is the positive pole, then this is positive and this is negative. So notice that the COM terminal is connected to the positive pole. So let's say since the COM terminal is connected to the positive pole, then the voltmeter will indicate exactly the opposite, which is negative reading. So it's not enough to specify whether it measures negative or positive reading. We need to specify also the value. So for sure it is negative, and its value is given by 18 volts. So it measures minus 18 volts. Now in 2.7 they are asking me to give with the justification the reading of the ammeter. So the ammeter is being traversed by the current I, so it's measuring the current I of value 0.5 amperes. So in this case it will either measure 0.5 amperes or minus 0.5 amperes, and this depends on the COM terminal. So if this is the positive pole going to the ammeter, so this is positive and this is negative. Notice that the COM terminal is connected to the negative pole. Since the COM terminal then the ammeter will indicate positive reading. So it is not enough to specify whether it indicates positive or negative. We need to specify the value. This is positive. What about the value? It measures 0.5 amperes. Okay. And by this we have finished solving this exercise. So that's it for me in this video, guys. In the next part we'll complete the explanation of this chapter.